Okay, well, I'm riding my bicycle, and I know that the radius of the tire is 1.5 meters. I also know that I travel 100 meters in 30 seconds. Now, what I'm looking for is the angular acceleration as well as the final velocity. But before I get started, I know that whenever I solve rotational dynamics, I like to find the revolutions, the radians, and the radians per second, just so I know I have all the information I need to solve any questions they might ask. So I know that the radius of this circle will equal 2 pi r. So I know 2 times pi will give 2 times pi times the radius, which is 1.5 meters, will give us 9.42 meters. Now this is really important because this is how far, this is the distance along the tire, so this is how much distance it's going to cover for every turn. Now, let's find the revolutions, how many times it turns for this 100 meters. So we know for the 100 meters, we know that 100 meters over the circumference will give us a revolution. So 100 times 9.42 meters gives us 10.6 revolutions. Now let's just find this in radians, and all we do is multiply this by 2 pi, and we get 66.7 radians. Now to find the radians per second, we're just going to go ahead and take this and then divide it by 30 seconds, which is the time it took to travel this whole distance, and you end up with 2.22 radians per second. Now let's go ahead and just find this angular acceleration, and we know that in this formula we have the change in the angle equals the angular velocity, the initial angular velocity times the time, plus 1/2 times the acceleration times time squared. Now we know that the initial velocity is 0 because the bike starts from rest. So we can go ahead and get rid of that, and we end up with the change in the angle equals 1/2 acceleration times time squared. So solving for A, we get 2 times the change in the angle over t squared. Now let's just plug in our numbers. We get A equals 2 times this angle, which we found out was 66.7 radians that it covers. So times 66.7 radians over the time squared, which is 30 seconds, and we end up with 0.15 radians per second squared equals the acceleration. Now, we know that we can just look at the units and we see that radians over seconds squared would give us radians per second squared, which is the units for the angular acceleration. Now, let's go ahead and just find the final velocity, and we know that the angular final velocity will equal the initial angular velocity plus the acceleration times the time. Now we know that the initial, like we said before, the initial velocity was 0, so we can get rid of that, put 0, plus the acceleration, which we just found, which was 0.15 radians per second squared, times the time of 30 seconds, and we end up with a final velocity of 4.5 radians per second. Now just looking at the units, we see again that radians over seconds squared times seconds will cancel out the squared, and we end up with just radians per second, which is the units for velocity.